We're going to be looking at finding inverses of functions and writing them as inverses of each other. Basically, what happens when you find the inverse of a function is you switch the domain and range. If we had the function 2, 0, 1, 3, 4, 5, and negative 1, 4. Now we know this is a function because all of our x values are different, and so we're going to call this a. Well, the inverse of this function, which we designate with a superscript of -1, this doesn't mean that we're wanting the reciprocal, we're wanting the inverse because it's written in function form, would be the set 0, 2, 3, 1, 5, 4, and 4, -1. So all we did was, what was the domain up here in the function became our range in the inverse function. What was the range became our domain. You switched the domain and range. And a lot of times we're needing this if we know what we want our answers to be, and we need to come up with a function that will generate those answers. Then we're dealing with inverse functions. Now, one way to tell if we have inverse functions is if we take f of g of x and we get x for the answer, and then we do g of f of x, our composition, and we get x for the answer. Then f and g are inverses of each other. And so what we would write there would be that f inverse of x equaled our g of x. And if we took f of the f inverse of x, then we're going to get x. And if we did the f inverse of f of x, we would get x. When we do our composition and we plug in the inverses of each other, then when we get x for our answer, then that says that our functions are inverses. And if you'll notice, the domain of f of x is equal to the range of f inverse x. So let's show that two functions are inverses of each other. Let's take the function f of x equals 4x minus 7, and g of x equals x plus 7 over 4. And we want to see, are these inverses? Well, to show that they're inverses, we're going to do f of g of x. That means we'll take the function f, wherever there's an x, we're going to plug in the function g of x. So we're going to have 4. In place of x, we're going to put x plus 7 over 4 minus 7. So we plugged in for x. Now when we multiply these 4's cancel, and we have x plus 7 minus 7, which is x. So f of g of x gave us x. Then if we did g of f of x, okay, we'd take our function, wherever there's an x, we'll plug in f of x. So we have x plus 7 over 4. So in place of this x, I'm going to put my function. So 4x minus 7 plus 7 over 4. Well, minus 7 plus 7 is 0, so I have 4x over 4, which is x. Therefore, that shows that these two functions are inverses of each other, because when you did f of g of x, you got x, and g of f of x, you got x. Uh, let's take these two. If f of x equals 3 over x minus 4, and g of x equals 2 over x plus 5. Well, if we take f of x and we plug in g of x wherever there's an x, then we're going to have 3 over 2 over x plus 5 minus 4. Well, simplifying that, we've got 3 over 2 over x plus 1. Need to get me a common denominator, which would be x. So that's going to give me 3 over 2 over x plus x over x, which would be 3 divided by 2 plus x over x. Now we know to divide by a fraction, we multiply by the reciprocal, so that's 3 times x over 2 plus x, which gives me 3x over 2 plus x. Now, I did not get x for an answer, so what that says is these are not inverses. When you put the function in, then you're supposed to get x. Now, that's how we can show that two functions that we already know are inverses. But at times we want to be able to take a function and find its inverse. Well, to do that, we're going to go through some steps. To find the inverse of a function, the first thing we're going to do is to replace the function, the f of x, with y. Then we will switch the x and y, solve the equation for y, and then replace y with f inverse x. So let's take at f of x equals 3x minus 1. Okay, we replace the f of x with y. We're going to switch our x and y, so I'm going to have x equals 3y minus 1. Then we want to solve for y, so we will add 1 to both sides and divide both sides by 3. So I get x plus 1 over 3 equals y. Now, if I wanted to prove that that was the inverse and that I had found the correct inverse, then I can go back and I can find f of f inverse. So I've got my f of x is 3x minus 1. My f inverse of x was x plus 1 over 3. Okay, if I find f of f inverse of x, then I'm going to take my function named f. Wherever there's an x, I'll plug in the inverse. So I'll have 3, and then in place of x, put x plus 1 over 3 minus 1. Well, my 3's cancel, and I have x plus 1 minus 1, which is x. And if I did my f inverse of f of x, then I'm going to take my inverse function. Wherever there's an x, I'll plug in f of x. Well, that would give me, in place of x, I'll put 3x minus 1 plus 1 over 3 would be 3x over 3, which is x. So I took my function, I replaced the f of x with y, I switched the x and y, and then solved for y. To show that they were correct, I went back and did my inverse test. Let's look at one more where we find it. Okay, f of x is equal to the square root of x. Okay, we're going to replace f of x with y. We're going to switch our x and y. Then we want to solve for y. Well, what we have to do is get rid of our radical, so we're going to square both sides. So y is equal to x squared, and that's our inverse. So f inverse x is equal to x squared. And I could go through and do the test. If I take f of f inverse, then I'm going to have the square root of x squared, which is x. If I do f inverse of f of x, then I'm going to be squaring the square root of x, which gives me x. So these are inverses of each other. You switch the x and y, and then you solve for y. Now, we want to be able to look at graphs and know from a graph if we have a function that has an inverse. Not every function has an inverse that's also a function. And so what we can do to tell if we have a function is we can use our vertical line test. So let's look at, say we have a graph of a parabola. Okay, if we do our vertical line test and draw a vertical line through any point on the graph, we can see that we have a function. Now, to know if its inverse is also a function, what we do is called the horizontal line test. If I do the horizontal line test, then I'm going to cross my graph in more than one place. So yes, I have this is a function, and so I can find its inverse, but its inverse will not be a function because it's going to cross your graph in more than one place. That inverse would graph to look something like this. And we can see that the inverse would not be a function. And you can think about it. For every x, we only had one y, but for every y, we had two different x's that would give you that y, so that says that the inverse would not be a function because we just switched the x and y's, remember. So if we're wanting to know if our functions have inverse functions, then what we do is we go through and we do the horizontal line test. You do the vertical line test first to see if you have a function. So this would be a function. Then you do the horizontal line test to see if it has an inverse function. And it makes it a fairly easy way to know if your inverse is also a function. If we had as our function, this is a function, but its inverse is not a function because if we did the horizontal line test, we're going to cross the graph in more than one place. And so what we have to do sometimes is then limit the domain on the inverse. Okay, well, you want to be able to take a graph and come up with the inverse of a function, even if you don't know the equation. We want to be able to graph it. So let's look at this one. Okay, here I have a graph drawn of a function. We can see that it passes the vertical line test and that its inverse will also be a function because it passes the horizontal line test. Now what I want to do is draw the inverse. Well, if you remember, what we do is we switch the x and the y. So one way of drawing it is by looking at your coordinates. The coordinate for this point is 0, 1. So if we switch that, then we have the coordinates 1, 0. Okay, the coordinates for this next point are 1, 2. So if we switch those around, then we have the coordinates 2, 1. At this point, the coordinates are 2, 4. So if we switch those, we have the coordinates 4, 2. And we could use other points, but those are the ones that we have. And so if we came up, this would be our inverse. This would be the graph of our inverse. Now, one of the things about the graphs of inverse functions is that they're symmetrical about the identity function. Remember, the identity function is the one that goes through the origin, and your x and your y's are always the same. And so we would be symmetrical. You can see if we folded it across the identity function, these would be on top of each other. But if you're given a graph of one function and you need to graph its inverse, then you can simply switch your x and your y's. Okay, we want to look at one last section where we're going to go through and we're going to find the equation for the inverse like we've done. And then we're going to graph both the function and the inverse in the same coordinate system. And then we're going to look at what we have as the domain and the range. So let's go through and do one of those. Okay, we're going to look at the function f of x equals x squared minus 4, and we're going to limit our domain to where x is greater than or equal to 0. Now, we've already graphed our parabolas. We've looked at, we could graph these by using transformations. We know that if we had our points, we'd have 0, 0, and then it says to move it down 4. We would have the point 1, 1, 1 squared's 1, and then move it down 4, 1, 2, 3, 4, and be at negative 3. We have the point at 2, 4, and then if we would go down 4, and if we graphed a few others of these, we would have our parabola that will keep on going, but we're only going to start at x equals 0. So we would have the parabola. Now, let's find the inverse. So we're going to replace f of x with y. We're going to switch our x and y, and then solve for y. So we'll add 4, and then take the square root of both sides. Now, when we take the square root of both sides, we always say plus or minus. That's a 4. And we've got plus or minus the square root of x plus 4 equals y. Okay, with the plus or minus there, we know that it's not a function. And so we're going to need to limit then our domain as we go through and graph this so that we're only graphing the functional part. And we know how to graph a square root. We know that we would use the points negative 1, 1, or 0, 0, 1, 1, 4, 2. But then what this did is it shifted our x values to the left 4 units. So if we looked at that, we'd have 0, 0, and we've shifted to the left 4 units. We would have the point 1, 1, and we've shifted to the left 4 units. We would have the point 4, 2, and then we would shift it to the left 4 units. And we would have our graph. And we would only deal with the one that was the positive. We wouldn't deal with the negative one because then we would not have a function. And so we've come up with our two functions and we've graphed them and we've seen that they are inverses of each other if we did uh, our line that would go through those, uh, the identity function y equals x, then we could see that those would be symmetrical about that. Now let's look at our domain and range. For our function that we had, the one that's in blue, our domain, we said x was greater than 0. And so our domain for it would have been 0 included to positive infinity. Now our range, we didn't have any values below -4, so our range was -4 to positive infinity. Okay, if we go to the red one that we did, the one that was our inverse, and we find our domain, well, notice our domain, the lowest x value was at -4, so it went from -4 to infinity. And then our range, our lowest value was 0. And then it went to infinity. Now notice what was our domain for the blue became our range for the red. What was our range in the blue was our domain for the red. Our domain and ranges simply switch. And we can graph them then and see what our values are. And if you need to make tables to do your graphing and plug in the points, that would be okay. Let's look at one last one. Let's say that we've got the equation f of x is equal to the cube root of x minus 1. Okay, and what we want to do here is just come up with the inverse of it. We're not going to actually graph this one. So we're going to replace our f of x with y. We're going to switch our x and y. Then we want to solve. Well, what we do to solve is we raise it to the reciprocal power, or we raise it to the same power as the root we're taking. So we're going to cube both sides. So we end up with x cubed is equal to y minus 1. So adding x cubed plus 1 equals y. Or that would be our inverse function. Our f inverse of x would be equal to x cubed plus 1. So we can even do it with higher powers. And if we wanted to, we could actually look at the graph of this one. We know what our cube root graph looks like. We have some specific points. We do -8, -2. And then what this says is we're going to shift our x value 1 unit to the right. So if we were at -8, -2, we shift it 1 unit to the right. If we're at -1, -1, we shift it 1 unit to the right. 0, 0, we shifted 1 unit to the right. We normally have 1, 1, and so we would shift that 1 unit to the right. And then we usually have 8, 2, because the cube root of 8 is 2. but then we're going to shift that 1 unit to the right. So this would be our function that we started with. Then if we graphed our inverse function, well, in graphing our inverse, we have a perfect cube. Well, we know that negative 2 cubed is negative 8, but then it says to go up 1. Negative 1 cubed is negative 1, but it tells us to go up 1. 0 cubed is 0, but then we go up 1. Uh, Normally then we have 1, 1, and then we go up 1. And 2 cubed is 8, and we will go up 1. So this would be our inverse function. Now in this case, our domain was all reals, and our range was all reals. Well, the same thing here. Our domain is all reals, and our range is all reals. And so we are able then to uh, come up with our inverse function. So what you need to be able to do is, given two functions, decide if they're inverses by substituting into the other function and seeing if you get x for an answer. If you're given a function and you want to find the inverse, then you will replace the y, f of x with y, then switch your x and y, then solve for y, and then replace that with f inverse x. And you need to be able to do some sketches of graphs, especially if you're just given the points, then you switch your x and your y. And these are our inverses.